Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
1985 Tim Berners-Lee Information Management, a proposal, the genesis of the World Wide Web, a ubiquitous presence that has reshaped the very fabric of human civilization, is arguably as much a product of visionary foresight as it is of serendipitous circumstances. Tim Berners-Lee's 1985 paper, Information Management, a Proposal, constitutes a crucial, albeit nascent, articulation of the architecture and operational principles that would, in a few short years, blossom into the global phenomenon we recognize today. This essay undertakes a rigorous, section-by-section examination of Berners-Lee's proposal, engaging directly with its claims, arguments, and underlying assumptions, with the goal of providing a critical evaluation of its internal consistency, predictive power, and enduring impact. It is an invitation to delve into the very blueprints of this revolutionary transformation, to apprehend the intellectual landscape from which the web emerged, and to appreciate the profound implications of Berners-Lee's groundbreaking vision. Section 1 Introduction. The problem of information overload. Berners-Lee begins with an astute diagnosis of the contemporary state of information management at the CERN laboratory, where he was employed. The central problem, identified immediately, is not a lack of information, but a surfeit, a deluge rendering it difficult to locate, coordinate, and utilize the collective knowledge of the organization. He observes the fragmented, proprietary nature of existing information systems, pointing out that different systems are incompatible, each holding its own distinct data formats and access methods. The resultant issue, as he portrays it, as systemic inefficiency, reducing the ability for members to share knowledge, collaborate effectively, and for projects requiring coordinated data to proceed smoothly. The claim here is that the current system produces a bottleneck, impeding communication and limiting productivity. The evidence presented for the claim is observational: the disparate nature of the tools, the limited scope of their shared functionality, and the proliferation of incompatible data formats. From this, Berners-Lee infers that to improve productivity, a general system, built upon the foundation of information sharing, must be devised. He does, however, recognize the inherent challenge, the scale of integrating disparate systems, as well as finding a common mode of data representation among them all. The immediate implication is that an integrated system, capable of handling a diverse range of data, will not only optimize workflow but also unleash the potential for collaborative. Section 2. The proposal: a decentralized, hypertext-based system. The heart of Berners-Lee's proposal lies in the vision of a decentralized, hypertext-based system. At its core, the system is presented as a network of interconnected documents, forming a vast web of information. Each document, to be stored on a server, is accessible via a unique address or link. The key element is the hypertext link, which connects one document to another, allowing users to navigate the information space seamlessly. The system is therefore conceptualized as a graph of information, where nodes are documents and edges are hyperlinks. The essential mechanism proposed is the universal access afforded by this interlinking. It is argued this form of organization will allow users to easily follow their chains of thought, traversing the information space in an intuitive and exploratory manner. Furthermore, Berners-Lee emphasizes the importance of a simple, extensible architecture. The system is meant to be flexible, allowing for the integration of new data types and features over time. He underscores the importance of the system's ability to adapt to the user's needs. The methodology behind this proposal relies on the use of a structured language for document creation, a standard protocol for communication, and a unique system of identification for each resource. The evidence relies on a conceptual framework, presenting an abstraction of how such a system should work. The logical coherence resides in its simplicity. The individual parts of the system are themselves easy to understand. However, its effectiveness, at this juncture, is theoretically predicated on the willingness of individuals to adopt these principles. Section 3T components nodes, links, Berners-Lee proceeds to delineate the key components of his proposed system, giving his attention to nodes, links, and addresses. A node, in his terminology, represents a piece of information, a document, or a data object. The primary characteristic of a node is its ability to be uniquely identified. The link, then, is the crucial element that connects nodes. The very act of linking is presented as the fundamental action enabling the interlinking of knowledge. Each link is associated with information that specifies its location. Utilizing a uniform addressing scheme, the address is viewed as the crucial mechanism, as it is the means by which users locate and access information. The claim is that address schemes and unique identifiers will facilitate collaboration between users. The analytical basis is pragmatic. A system without unique addresses would collapse into chaos. Therefore, any system desiring to represent information in a networked format requires a method for identifying the precise resources to which the links refer. His rationale is anchored by the assumption that the system must be able to reliably find and share data. Section 4. The benefits of hypertext. Berners-Lee directly addresses the benefits of a hypertext-based system. The advantages are twofold: streamlined navigation and enhanced collaboration. He argues that hypertext allows users to explore information non-linearly, following their particular lines of inquiry, giving more flexibility. Moreover, by creating an environment enabling the collaborative sharing of information, hypertext encourages collective intelligence and accelerates the pace of discovery. The core claim rests on the capacity of hypertext to overcome the limitations of sequential, linear information systems that are inherently less adaptable to the complexities of human thought. Berners-Lee is in effect advocating for a more organic, less rigid model of information access. His arguments are supported by observations of how humans engage with information in everyday settings, often making jumps to adjacent ideas to construct their understanding. The logical structure is compelling, because he posits hypertext as an optimal design choice, designed around the inherent human cognitive capacity for making associative connections. The implications are, and would indeed become, far-reaching: the democratization of access to information and, by extension, the potential for a more informed and collected global community. Section 5. Data management and organization. The essay proceeds to deal with the crucial aspect of data management and organization. Berners-Lee suggests that the key is to make the process of writing and managing information as simple as possible. He recommends a modular approach, building blocks of information arranged in a manner that allows for flexibility and scalability. He proposes several methods for organizing the data: the use of a common data format, simple metadata, and a structured approach to document creation. The central claim is that a well-organized system, capable of handling a variety of information objects, is essential. He emphasizes a need to keep the system as simple as possible and stresses the importance of maintaining control over information. The supporting evidence comes from observations of existing information management methods. Berners-Lee is particularly concerned with a lack of standardization in the existing systems. His suggestions are pragmatic, aimed at maximizing the usability of the system. His implied argument is that effective organization will reduce the friction inherent in information access, making the system usable and efficient. Section 6. Technical considerations, protocols and standards. Berners-Lee now moves to the technical considerations, specifically relating to protocols and standards. He emphasizes the need for a standard transfer protocol, enabling users to easily share information. The argument is made that this system will be much more useful if documents can be shared and if information can be extracted from them. He argues for a common language for document description, facilitating interoperability between systems. The suggested approach calls for simplicity and flexibility, advocating for a standard that can be easily adapted to changing needs. He also suggests a clear and straightforward naming convention. The underlying claim is that interoperability and standardization are vital for realizing the potential of the proposed system. His arguments are supported by the historical precedents of early networks, which demonstrated the necessity for adherence to well-defined protocols. Berners-Lee's vision depends on several key assumptions: that a sufficient number of users will adopt the standardized protocol, and that the protocol will remain adaptable to emerging technologies. Section 7: Implementation and Deployment. The essay then focuses on the practical matter of implementation and deployment. Berners-Lee addresses the steps required to create and deploy the system. He proposes a phased approach for development, starting with a small-scale prototype. The logic is that, by developing a small prototype, it will be easier to identify and address potential. He suggests that adoption be approached in an iterative manner, with user feedback informing further development. The claim is that incremental development will reduce the risk of failure. The underlying argument is that the process of building the system should be user-centric, and that the design should be open to modification. His methodology focuses on the testing of a limited version of the system. The evidence is, in this case, not based on data, but on speculation. The implications are that the implementation method is critical. The entire system's eventual success is presented as hinging, in large part, on the practical application of a well-conceived plan of deployment. Section 8: Potential Applications and Future Directions. Berners-Lee concludes the essay by exploring the potential applications and future directions of his proposed system. He envisions the system being used to share information within the CERN laboratory, but also foresees wider applicability. He stresses the importance of the system's open design, allowing it to evolve and to adapt to unanticipated uses. He predicts the system's ability to be used to integrate disparate data systems. The central claim here is that the system has the capability to transform the very nature of information management. The proposed system is not seen as a fixed product, but as a foundation. His arguments are supported by the assumption that the system is adaptable. Berners-Lee's vision stretches beyond the confines of his immediate environment. The implications of the proposed system are enormous, hinting at a future in which information flows freely, connecting people and ideas, fueling innovation on a previously unimaginable. Section 9: Evaluation of core arguments, strengths and weaknesses. A critical evaluation reveals several strengths in the information management. A proposal: Berners-Lee's identification of information overload and the fragmentation of existing systems hits the mark, providing a clear articulation of the problem that needs solving. His proposal for a decentralized, hypertext-based system represents a prescient solution. The focus on simplicity, standardization, and adaptability are all correct. The emphasis on the user-centric design approach is commendable. However, some aspects of the proposal exhibit relative weakness. The paper, at this stage, does not consider the question of security, which would become a crucial consideration. The paper downplays the challenges of scalability and data management that would, in time, become significant. Furthermore, the proposal leans heavily on the assumption that users will readily adopt the proposed standards. Section 10: Contextualization, the intellectual landscape. To fully understand the significance of Berners-Lee's work, it is essential to consider the context of the intellectual landscape that gave birth to this proposal. The paper emerged at a time when distributed computing was gaining traction, yet the concept of a globally accessible network was still nascent. The idea of hypertext, albeit explored previously, was not yet widely utilized. Berners-Lee, as an individual working at CERN, was influenced by a confluence of several factors. He was immersed in the culture of open collaboration and the desire to facilitate information sharing. He drew upon the work of several key precursors, including Vannevar Bush, who, in his 1945 essay, as we may think, proposed the mimics, a conceptual machine for organizing and retrieving information. Ted Nelson's work with Project Xanadu, although yet unrealized at this juncture, contributed to the conceptual framework. These factors and many others were present, and all played a role in the development of Berners-Lee's vision. Section 11: Reception and Influence. The immediate reception of information management a proposal was less dramatic than the eventual outcome would suggest. The paper was circulated within CERN, serving as a catalyst for further work. The impact, in these early stages, was largely internal, influencing the design decisions of early web projects. The paper's emphasis on decentralized control and open standards promoted rapid innovation and expansion. The paper was not published widely at the time. Its influence was primarily through word of mouth and its role as a source document for the development of the core technologies. Its influence can be seen in the subsequent development of the World Wide Web. Section 12: Subsequent revisions and elaborations. Berners-Lee and his colleagues would, over the next several years, continue to refine his proposal, developing the essential protocols, languages, and technologies that would transform his vision into a reality. The development of the Hypertext Transfer Protocol (HTTP), the Hypertext Markup Language (HTML), and the Uniform Resource Identifier (URI) were crucial steps toward realizing his original proposal. These innovations, and more than their technological advancements, they embody the core principles of openness, the centralization, and universal access that were at the very heart of Berners-Lee's original. In Section 13: Long-term significance, a revolutionary transformation. The enduring significance of information management a proposal stems from several crucial elements. The paper provides a clear diagnosis of a pressing problem and offers a visionary solution, a solution that would later reorganize human society. It laid the foundation for a system that prioritizes accessibility, interoperability, and user control. It also serves as a powerful illustration of how a clear vision, combined with practical implementation, can have a revolutionary global impact. The legacy of this work is not merely that it ushered in the age of the web, it reshaped the ways in which we communicate, collaborate, and access information. It has created a global platform for innovation, making it possible for individuals and organizations to connect, learn, and create on a scale previously unimagined. Conclusion: the blueprint for the information age. In conclusion, Tim Berners-Lee's 1985 paper, Information Management, a Proposal, represents a foundational document in the history of the World Wide Web. Its significance is not that of a definitive plan, but as a blueprint, a set of ideas and guiding principles that served as the foundation for a global transformation. The paper's strengths reside in its insightful identification of the problems of information overload and fragmentation, and in its visionary articulation of a solution, a decentralized, hypertext-based system. Its emphasis on simplicity, open standards, and user-centric design proved pivotal in the rapid development and widespread adoption of the web. While the paper acknowledges some weaknesses, they become insignificant in light of its transformative impact. This work, born from the needs of a scientific institution, would, in time, reorganize nearly all human activities, and it remains a testament to the power of vision, innovation, and the enduring human desire to share knowledge and collaborate. It is a document deserving of sustained attention, a study of the birth of the information age, built on open communication.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.